think now we should continue. Sorry. Sorry again, students, for the delay. And now it's all sorted. We are going live. Now listen to me. Okay. Just listen to me. This solid body, this solid cylindrical body is being inserted or being dipped in the liquid. Clear? Now, what you can say that liquid in the in the container will start rising, will start rising. Or you will say that liquid that comes out that is being displaced by this solid body has the same volume as that of the solid. Again, you are not getting what I'm saying. I am saying that when you insert a solid or a body in a liquid, then some liquid is being displaced by the solid. Now the volume of the solid, now the what I'm saying, if the punchline is here, the punchline is the volume of liquid displaced. Who is displacing the liquid? The solid being inserted is displacing the liquid, is equals to the volume of solid dipped. The volume of solid dipped. Okay, that there might be a confusion. There might be a confusion. I will clear the confusion in the sentence itself. Volume of immersed part of solid. That's the first thing that you should know or you should remember in mind. If I speak in Hindi, then the sentence will become जितना पार्ट सॉलिड का डिप करेंगे उस वॉल्यूम के इक्विवेलेंट लिक्विड डिस्प्लेस होगा. दिस इज द थिंग दैट आई एम सेइंग. ओके, नाउ इज इट क्लियर? Then Archimedes principle says the buoyant force on the body or on the solid is equals to the weight of this displaced liquid. You can see it here. What is it? The buoyant force on a body partially or completely dipped. This is another part, is equal to the weight of the fluid displaced by the body. Weight of the fluid displaced by the body. Is this clear? Now, if I say in simple words, when you dip a solid, some liquid gets displaced. The volume of the liquid displaced is equal to the volume of the solid submerged or immersed. Next thing is the buoyant force on the solid is equals to the weight of the liquid displaced. So I will say the force is F, buoyant is B. So the buoyant force is equals to the weight of the weight of liquid displaced. This is actually the Archimedes principle in a simple sentence. Now I will write it in terms of expressions. Then expression will be weight of something is what? Mass into G. Weight of something is what? Mass of the liquid into G. Is it clear? Now mass of the liquid, you know the relation mass is equals to volume into density. Mass is equals to volume into density. Let the liquid that is filled in the container, volume of the liquid filled in the container, let its density is rho. Density is rho. Then this volume, you can write buoyant force is equals to mass is equals to volume into density. Volume of liquid displaced into density of liquid into G. I think it is clear. So the punchline is buoyant force acting on a body is V rho G. And you will remember that V is the volume of the liquid displaced, rho of the liquid, rho is density of the liquid into G. Another thing, I have told you that volume of the liquid displaced is equals to the volume of the immersed part of solid. So you can also write as buoyant force is equals to volume of immersed part, volume inside. V in is the volume inside of what? Of solid body into density of liquid into G. Now, I must ask or I will ask, don't get confused in the formulas. Keep small things in mind. Keep this punchline in your mind and everything will be sorted. I hope it is clear. Buoyant force is equals to volume. Either you can use volume of liquid displaced, and volume of liquid displaced is nothing but the volume of solid inside the liquid. V in into density of liquid into G. So keep these formulas, keep these relation in your mind. And this is all about Archimedes principle. Now we can also prove it on the next slide. I am going to prove this relation. Have a look at that. Again, consider a solid body. Look at that. This is a container. Container has some liquid of density rho and a solid is immersed in it. Consider the atmospheric pressure is P naught and the top of the surface is at a depth h1 from the liquid surface and the bottom surface of the solid is at a depth h2. I think the situation is clear. Then one more thing I'm saying, that pressure at this end is P1, let's suppose, and pressure at this end is P2. Due to this pressure, there will be a force. There will be a force. Let this force is F1 and F2. So the situation is like that. The body is this one. On the top surface, there is a downward force F1. At the bottom surface, there is a upward force F2. And the difference of these two forces is known as buoyant force. And the difference of these two forces is known as buoyant force. So the buoyant force will be so the buoyant force Fb will be the difference of these two forces F2 minus F1. Now you just need to write the values of F2 and F1. So you can write it here. F1 is what? Do you remember the, let this area is A. Area of cross section is A. So force is equals to pressure into area. Is it clear? Force is equals to pressure into area. You know that, na? Now, pressure is what? At point at this surface or at the top surface, pressure is what? You will say pressure is P1 is equals to atmospheric pressure P naught plus rho G H1 into A. This is force 1. Now you are getting confused. If you have not studied the previous classes, then you might get confused. Listen to me. Pressure varies with height as a relation rho g h. It increases with the depth. So at the top surface, height is h1, so pressure is rho g h1, but there is a atmospheric pressure P naught. We can omit this as well. Now F2 is what? P2 into A, and P2 is what? You will say, sir, atmospheric pressure is P naught plus depth is h2. So you can write rho g h2. This is what? Pressure into area. Area is what? A. Now place these values F2 and F1. I will place these values. So buoyant force is equals to F2 minus F1. If you subtract these F2 minus F1, then what you will get? Can you see that A will be common? So A will be common. So it will become P2 minus P1. P2 minus P1, and this relation is P naught plus rho g h2. This is what? This one minus this one minus P naught minus rho g h1. P naught and P naught will get cancelled. So buoyant force will remain A rho g h2 minus rho g h1. What is rho? Rho is the density of liquid. Now again you can see that rho and g is also common. A is already there. What's left? H2 minus H1. Now ask yourself, what is H2 minus H1? What is H2 minus H1? Can you say that H2 minus H1 is the height of the cylinder? H2 minus H1 is the height of the cylinder. Yes, then we can write it as buoyant force is equals to rho g A into H. This A into H is nothing but the volume of the cylindrical body. Is nothing but the volume of the cylindrical body. So A into H is the volume of the cylindrical body. What is rho? Rho is the density of the liquid. So buoyant force, I will write rho is the density of liquid into G into volume. A into H is the volume of what? Inside the liquid. That's what we need to prove. That's what we need to prove. The terms might be shifted, might be altered in left and right. Otherwise, the relation is same. Volume of immersed part G into density of the liquid. This is what buoyant force. I think things is clear. Now, the buoyant force is, as you already know, that buoyant force acts in the upward direction. So I don't need to mention that the direction of buoyant force is upward. Okay, clear? Now, moving further. Flotation. Flotation is the word used when a body floats in a liquid. When a body floats in a liquid. Floating means it just in equilibrium. This is the condition of equilibrium that is called flotation. Now again have a look at that. Can you see the diagram here? Again, there is a container, vessel, there is a liquid filled in it, and a body is immersed in it partially. Body is immersed in it partially. Now, what you can see, the equilibrium condition is, for that, just notice one thing. If I say that when a body is dipped in a liquid, a buoyant force acts on it. So there will be a buoyant force FB. acting on it. We can calculate the value of this buoyant force. There is no issue with that. And another force is the weight of the body. Weight of the body. And the weight of the body is nothing but, you will say, mg. Are you getting my point? So there are only two forces acting on the body. One is buoyant force, other is weight of the body. So for the equilibrium, these two forces must cancel each other or must be equal in magnitude and opposite in direction. So they are opposite in direction, so they must be equal. So what we can say, for equilibrium, this buoyant force must be equal to the weight of the solid. Now I am taking a pause. There are different words. In the previous slide or in the Archimedes principle slide, we have used the weight of the displaced liquid. Now I am taking the weight of the solid. Are you getting why I am taking such things? Equilibrium means that upward buoyant force should be equal to the downward weight. Weight of what? Weight of solid. Clear? This is the condition of flotation. If this condition satisfies, then the body floats. If this condition satisfies, then the body floats. And if this condition fails, like if weight of the solid is more than that of the buoyant force, listen to me again. If weight is more than the buoyant force, then the body will sink. If the weight is less than the buoyant force, then body will go to the surface of the liquid. Clear? So for the flotation, the condition is buoyant force should be equal to the weight of the solid. Now, after all these discussions, we will discuss two questions here, and after that, we will move towards fluid dynamics. If you have any doubt, you can ask me anytime. Moving further, look at that. So, you have 1 minute of time. Please try to attempt the question. Okay. Anyone? This is a very simple question. Actually, look at that. First thing that I have seen, that mass of the solid cube is given floats. That means it's in equilibrium. How much volume of the cube will remain outside the water? Now listen to me. What I'm saying, I don't know what is the volume outside the water. What I know that for equilibrium, buoyant force should be equals to the weight of the solid. Should be equals to the weight of the solid. And weight of the solid is nothing but mg, or I will say weight of solid we are going to write. So solid into g. Complete weight of solid into g. Clear? Now, what is buoyant force? We have learnt about the buoyant force. Buoyant force is nothing but, if I change the color of the pen, buoyant force is nothing but you have learned that volume inside into rho into g. You should remember the formula. Buoyant force is what? Volume inside into rho into g. Rho of liquid, volume inside of solid. So I am writing it here. Volume inside into rho of liquid into g is equals to mass of solid into g. You can see g will get cancelled. So again, if I write volume inside, and they are asking me the outside the volume outside. So there is no problem. We know the volume, total volume, like side is known. So we know the total volume of the solid. If we calculate the volume inside, then outside can easily be calculated. Clear? So volume inside is, I will write volume inside into density of liquid is what? Is given as 10 to the power 3 kg per meter cube. Or you can say 1000 kg per meter cube. Is equals to mass of the solid. Mass of the solid is what? I think it is given as 700 gram. 700 gram. Gram can be converted into kg. Is it clear? So it will be 2020. So volume inside is equals to 7 into 10 raised to the power minus 4. Clear? This is the volume inside the liquid, and we are asked the volume outside the liquid. Then the total volume V is, side is 10 centimeters, so 10 centimeter is 1000 into 10 raised to the power minus 6. Clear? This is the total volume. This is the total volume. Array, centimeter is converted into meter cube, na? So that's why I have written 10 power minus 6. Otherwise, cube is side into side into side. 10 into 10 into 10 is 1000. 10 raised power minus 6 meter cube. Or you will say 10 into 10 raised to the power minus 4 meter cube. Clear? So this is volume total. This is volume inside. So outside volume will be, if I change the color, so V outside will be V total minus V inside, and V total minus V inside will be 3 into 10 raised to the power minus 4 meter cube. Let's check the options. So the options are in the centimeter cube. Options are in the centimeter cube. So the correct option is option number A, that is 300 centimeter cube. That is 300 centimeter cube. Is it clear to you? Listen to me again. Whenever you see the term float, whenever you see the term floats, you need to apply the equilibrium condition. And equilibrium condition, buoyant force is equals to weight of the solid, and write the formulas, write the relation, and everything will be sorted. Is it clear? Now moving for the next question. It is again a very good question. It will clear more concept. It will give more concept clarity to you. Focus on that. Try to solve it at least. 1 minute of time. At least find out some something in it. At least you should remember the data. You should analyze the things, what to do, what not to do. Okay. So from the previous question, there is a difference. In the previous question, mass of the solid was given. Now the mass of the solid is not given. Clear? Clear. Next thing is, in the previous question, the volume outside was asked. Now they are not asking the volume, they are asking the height of the block above the mercury level. So there are two differences. One is the thing they are asking is not the volume, is the height. The second thing is, if I draw the diagram, like this is a container. This is the container. It has some liquid up to this level. Let's say I'm just drawing the upper level, and the liquid is filled completely in this below portion as well. To this level, there is a liquid. Now there is a solid block. Mm, 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 mm. Let's say this is the solid block, which is of cubical in nature, cubical block. I'm not drawing the complete cube. I am just drawing the front view like this. This is a cubical block, suppose. Some portion is inside, some portion is outside. So they are asking that height of the block above the mercury. This is mercury. This is mercury. Mercury is what? Hg. I think, if I am not wrong. The chemistry is not that good. Yeah. Okay. Height of the block above the mercury level पूछी गई है. So I am taking, okay. I am considering it, let's suppose the height above the mercury level is h. Okay. Then you know the total side of the cube is 5 centimeter. If this side above the mercury level is h, then remaining side will be 5 minus h, if I am not wrong. Clear? Is it clear to you? Now, all other sides are 5 because cube has 3 sides, na, length, width, and height. And I am breaking this height is h and 5 minus h. But the base, this portion will be 5. And the width of this portion, width of this cube is also 5. Now, again, I have seen the term floating. Whenever I see the term floating, I will just apply the conservation, I will just apply the condition of equilibrium. So if I start with the solution part, what I will say, that buoyant force acting on it must be equals to mass of the solid into g. No issue with that. Clear? And buoyant force is what? Buoyant force is what? Volume inside into density of liquid into G. Is it clear? Is equals to mass of the solid into G. Mass of the solid is what? Mass of the solid is what? Actually, mass is not given. So we need to calculate the mass as well. Mass is what? You know the formula. Mass is density into volume. I think you know the relation. Mass is equals to density into volume. So I am putting the values. Mass is equals to density. Let's suppose density. Now, tell me, we are calculating the mass of the solid. We are calculating the mass of the solid. So mass of the solid is what? Density of solid into its volume. So density of solid is, let's suppose, sigma of solid. I am denoting the density with sigma into volume of solid into G. So again, you will see G will cancel out. Volume inside. Inside volume is this one, na? If you calculate this volume, you will say, sir, two sides are 5 into 5 and one side is 5 minus h. So you will write volume as 5 into 5 into 5 minus h. This is volume. Now, density of liquid. Liquid is what? Mercury. Mercury's density is given as 13.6 gram per centimeter cube. I am taking side in centimeters and the answer is also in centimeters. So I will not change the density into kg per meter cube. So I am directly writing is 13.6. Density of liquid is equals to density of solid. Density of solid is given somewhat. Solid is what? Iron. Iron density is 7.2 gram per centimeter cube. So that is 7.2 into volume of solid. So the total volume of solid, we have to write the total weight, na? So total volume of solid is 5 into 5 into 5. 5 into 5 into 5. Now you just need to solve it out. I am not going to solve. I think I should not solve. Actually, I can see that 5 into 5 will cancel out. So what will remain? 5 minus h into 13.6 is equals to 7.2. This is what remaining. Clear? So if you solve it out, you will get h is equals to 2.35 centimeter. If you solve it out, you will get the answer. And the correct answer is option number A, 2.35 centimeter. Now, clarify one or two things in your mind. Every time students get confused in writing the densities and volume, which volume should I consider? Which density should I consider? So I think these two questions will clear all of your doubts. So I will move further towards fluid dynamics. Let's start. Fluid dynamics. In the first class or first lecture of the fluid mechanics, I have told you that fluid dynamics is the branch of physics in which we deal with the flowing fluid. When the fluid flows, when the liquid flows, when the gases flows, we deal with that flow. So when the liquid is flowing, there comes a few types of flow, like steady flow, non-steady flow, streamline flow, turbulent flow. There are so many flows, so many type of flows that we are going to deal with. So first of all, we are dealing with the steady flow. Just listen to me. Okay. A simple definition is on your screen. Listen to me. I will change the color of the pen. I will say, okay, suppose, let's suppose this is a pipe, whatever may be the cross section of the pipe. Let's suppose this is a pipe. Pipe, you know the pipe from which liquid flows actually. This is a tube, you can say. This is a tube or this is a pipe, somewhere a region from which liquid is flowing. Now, if I consider any point, like if I consider a point A, this is a point A, clear? And if I focus only at point A, if I focus only at point A and the particles passing through the point A, like liquid is flowing now, liquid is flowing this way, like this, liquid is flowing. What I'm saying that if I focus all the particles passing through this point A and all such particles have same velocity while passing through point A, then this flow is known as steady flow. You are not getting my point. The main condition for steady flow is if all the particles passing through a same point have the same velocity, then this flow is known as steady flow. Is it clear to you? Again, if I say, if I choose another point like this point, if I choose another point B here, this is point B. And if I focus all the particles passing through point B and if they also have the same velocity, then this flow is known as streamline flow. Now there is a confusion that might be created in your mind with my sentence. Let's suppose all the particles at point A has V1 velocity and at point B has V2 velocity. Can you say that V1 is always equals to V2? Can you say that V1 is always equals to V2? What I have told you, particles passing through a particular point, all the particles passing through a particular point have same velocity. Like this is, suppose this is particle 1, this is particle 2, this is particle 3. Sorry for the interruption. Then all these particles while passing through point A will have the same velocity of V1. But when these particle passes through point B, they will have same velocity, but that velocity is not going to be equal to V1. It should be equal to V2. That means there should be a difference, or there may be a difference in velocity. It is not always true that these 2 points will have same velocity. One thing is clear, steady flow is clear. Now, you can ask me if there is a doubt. Now, moving further. Or you can say, if I write it in words, like this one. Hmm, where we were here. Pen. If velocity, pressure, and the density at any point in the flow do not change with time, pressure is not changing, velocity is not changing. That means rate of change of velocity, dv over dt, is what? Zero. Because velocity is not changing. Another condition is pressure is not changing. That means dp over dt is also zero. Another condition, density is not changing. That means rate of change of density is also equals to zero because they are not changing. And what about that? V1 is not necessarily equals to V2. In some situations, V1 may be equals to V2. So I'm not saying that V1 is, this condition is not always true or not always true. I'm saying V1 is not necessarily equal to V2. It may be equals to V2 in some situations. So that we will learn in which situation V1 is equals to V2. Okay. So now there is another situation, there is another uh, heading. You can see streamline flow. There is another type of flow. Before going to streamline flow, I will say that what is non-steady flow? What is non-steady flow? in which all these conditions are false, then this is called non-steady flow. So streamline flow, again, consider there is a tube. You can see this is a tube from which liquid is flowing like this, and liquid is coming out like this. Clear? So the condition is for the streamline flow, consider a point A. Again, consider a point A. Clear? This is point A. If all the particles, listen to me very carefully, if all the particles passing through this point A follow the same path, follow the same path, then this flow is streamline flow. You are not getting my point. For example, all the particles passing through point A will definitely pass with point B, or will definitely pass through point B. That means if a particle is passing through point A, then it will definitely pass through point B. Then such a flow is known as streamline flow. Again, if I say, if a particle passing through point C, then it will definitely pass through point D. That means all the particles follow the same path during the flow. All the particles follow the same path between 2 points is called streamline flow. Like if I say, if I go this way, then all other particles behind me will follow me blindly, will follow me blindly. There is a proverb in Hindi, Lakeer ke fakir. You should remember this line. If Akshay sir is going on that path, all the students will also move in that path. So that is called Lakeer ke fakir. I think you don't know Hindi. So should be a verb in English as well that I don't know. So there is no issue with that. I think you are getting my point. If a particle is following the path AB, then the all other particles behind it will start following the path AB. If another particle follows the path CD, then all other particles also follows the path behind it follows the path CD. So that means there are few lines forming in the flow, and such flow is known as a streamlined flow. If you want to see it in a definition form, then you can see it here. This is the definition that is mentioned here. You can take a screenshot, whatever you want to do. You can click the picture, you can click whatever. This is what streamlined flow. Again, moving further. Now, the path of this flow, the path of these particles, like this AB path, AB is a path, another CD is a path. So these paths are known as line of flow. These paths are known as line of flow. You can see that. Again, the same thing like this. This is the path AB. This is the path CD. This is going to be another path. So what I'm saying, these are the line of path. So what is line of path? Line of flow, basically. Line of flow. The path followed by particles between any 2 points, like this is point A and this is point B. Between any 2 points is line of flow. Clear? Again, one more thing, one punchline here. If I draw, listen to me very carefully. If I draw a tangent at the line of flow, this is the same thing that you will learn in the electrostatics and magnetism. That this is the punchline I will say. The tangent at the line of flow will give the direction of, you can say, velocity, or you can say direction of motion, or you can say direction of motion. Again, this is a very important thing. Listen to me very carefully again. What if I say that at this point, if I draw a tangent, this is not the proper tangent. If I draw a tangent, then this tangent will give the direction of flow at that point. Clear? And one thing that I have already told you, that all the particles on this at this path will have the same direction, then one can conclude that two lines of flow, can never intersect. Why they can never intersect? Because if they intersect, then at the point of it, like suppose there are two lines of flow, this one and this one. Then at the point of intersection, there will be two tangents. We can draw two tangents. So what tangent gives? Tangent gives the direction of velocity, direction of motion. So at the point of intersection, there will be two directions of motion. And what I have told you, that in streamline flow, particle follows the unique path. Particle follows the unique path. They follow the unique path. So that's why there it is not possible to have two directions. So these two are the punchlines that you need to remember. Two lines can never intersect, and the tangent at the line of flow gives the direction of velocity or motion. Now, again, moving further, tube of flow. This is again a very simple thing. For a streamline flow, if I talk about, consider the situation. Like suppose this is a larger pipe. This outer portion is a larger pipe in which liquid is flowing in a streamline. Liquid is flowing in a streamline flow. Now, what is tube of flow? Group of, a simple definition, group of line of flow. If you collect lot of line of flows, then this group is known as tube of flow. One thing is that, very simple thing. The main thing that you should learn, actually, consider any cross section area and the lines in it, like this. These are the line of flows, and this collection is known as tube of flow. This collection is known as tube of flow. So what is tube of flow? Group of line of flows is known as tube of flow, one thing. Another thing that you need to understand, every line of flow follows the same path, follows the unique path. I will not say same path, I will say unique path. And they will not intersect with each other. They will not, or they cannot intersect with each other. That means you can say that any line of flow in the first tube can never interact with the any line of flow of the second tube. Is it clear? Is it clear? That means in any two tubes, in any two tubes, for a streamline flow, liquid can never intermix. Liquid can never intermix. That means if you consider a tube of flow, then liquid can neither leave the tube, can nor enter the tube. You are not getting whatever I am saying. Just listen to me very carefully. Two line of flows can never intersect each other. Is it clear? Now, next thing is that if I consider a group of lines like this is a line, this is a line, this is a line. This is a streamline flow, and this collection is known as what? This collection is known as tube of flow. Consider a nearby line of flows. Again, this is another tube of flow. You can draw as many tubes you want. The main thing is that these two lines can never intersect. That means in a tube of flow or in a tube, liquid can neither leave the tube nor enter the tube. That means mass of the liquid remains conserved. Mass of the liquid remains conserved. That's what is our punchline. That is what our punchline. What is the punchline? Between any two tube of flows, liquid does not get intermixed. Liquid does not get intermixed. That means mass of the liquid in a tube remains constant. The conclusion of this line is mass of the liquid in a tube remains conserved. Remains conserved. That's what the main thing is. And after that, we will start some continuity equation. That is going to be our next topic. Today's session should be ended right now because time is over. So I'm ending the session. Till then, goodbye.
Okay, well, we'll go through the next question. Is it clear for everyone, right? Let me know in a chat box meantime if you are not understanding the problem, right? Is it recording right? Just let me check it. Yeah, it's recording. Cool. Next question. Yeah, here it's the next question. Find the velocity of a particle if the position of a particle is x is equals to 2t square. Okay, the given position at time is equals to 2 seconds. Look at this side. Here they mentioned 2 seconds. I will write this one here. No need to worry about it. 2 seconds. Okay, they're asking the velocity. Okay, देखो इधर x is equals to 2t square. Okay, position it is. If you want to calculate the value of velocity means you need to differentiate this position with respect to time. Right, what I'm saying? If you're going to differentiate this one, मान लो velocity is equals to d by dt of x is equals to 2t square. Right? Well, now, oh, just a minute. Pardon. Okay, I need to put the value of x right here. Okay, why I'm substituting that one? Look at it. D by dt of 2t square. Clear? Okay, now we need to differentiate this equation. You know differentiation. If you're going to differentiate this one means you will get here 4 times the t. This is what the velocity. But they're asking the velocity at 2 seconds particularly. Okay, when they will ask like this, you need to give the answer by their respective time. Hence, it will be 4 into 2 seconds. Means it is nothing but 8 meter per second. This is the velocity at 2 seconds. Let me know, guys, how many of you understand this question? Meanwhile, if you had any doubt, please drop your doubt in the chat box. Don't forget. Okay, that's great. Check by in your hand. If you're getting any different answer also, you can drop your answer in a chat box. Meanwhile, if I'm ready to correct it. Clear enough? Cool. Well. Excellent. Okay, well, we'll go to the next question. Dekho, a particle performing simple harmonic motion. Guys, what are the important points they will express in the sheet now? Try to underline it. Simple harmonic motion. Amplitude A start from x is equals to 0. Okay, you will get some idea here. X is equal to 0 means you need to draw some coordinates here. Okay, to understand. And it reaches x is equals to a by 2 by the time of 2 seconds. In 2 seconds, it will rise to a by 2 amplitude. Okay, find the time required to the particle to go from a by 2 to a. Wonderful question. Look at here. How to solve this? आपको wave आता है ना लिखने के लिए? This is wave, as I guess. I think you know, guys, right? Now, I will write one wave for better understanding. To better understanding, I will write one wave here. Yes, done. Okay, this is the wave. We know that this is the amplitude A. They given this particle, actually it is doing simple harmonic motion. Okay, well, it is starting from x is equals to 0 means origin, it will be starting from origin. And it is taking time, 2 seconds. Kitna? 2 seconds to reach the amplitude a by 2. Right? To reach the amplitude a by 2. Right? And then next to that, when it will be reached a maximum amplitude, we need to calculate. Means from a by 2 to a. This journey, to do this journey, how much time it is taking, we need to calculate. Right, what I'm saying? Right? Like this, you need to first imagine the wave and then you need to calculate the answer. Okay. There are actually only 2 options here. Remaining 2 are missed from this question. No need to worry. Okay. I will say. Before that, we need to write the wave equation. Wave equation क्या होता है? Y is equals to A sin omega t. A sin omega t. Now, Y, it is an amplitude of a wave at any time. Okay, they are saying like that in 2 seconds it is going up to a by 2. Now, I will write first a by 2. Dekho, in the place of y, I am writing a by 2 is equals to a sin omega t. I know the time here, t. This time I know. That's why I'm treating this one. Okay, from a say a class. Okay, take sign to left hand side. It will become sine inverse of 1 by 2 is equals to omega t. Right? I know the value of sine inverse of 1 by 2. It is nothing but sine 30 degree. Sine 30 degree, we can write this one as an pi by 6 or 3. May I know? May I know in a chat box? Exactly. Pi by 6. Very good. Okay, pi by 6 is nothing but sine 30 is equals to omega t. Okay, well, now look at here. This is a omega value. Time, we know that up to a by 2, time it is taking 2 seconds. They given in the question where it is here. Look at there. Look at in the corner. They given 2 seconds. Okay, now if I am going to substitute here 2 seconds, it will becomes to denominator here. Hence, omega value we will get here pi by 12. 12 pi by 12 हो गया. Okay, cool. Why I calculate omega now? I will tell you. Because I need to know the time which it will be take to move from a by 2 to a. This one. I'm doing yellow color, right? This journey I need to calculate. Right now? That's why I took this equation. Now, when it will be reaches maximum, then amplitude hota hai na? Y equation. Y a is equals to a sine omega t. Total time it is. I don't know the total time. We'll calculate the total time and then we'll minus this one. Easy, simple. Look at here. From a it will be cancelled. Take a to this side means sine inverse of it will become sine inverse of 1 is equals to omega t. Now, what will be the total time it will take from 0 to a? We need to calculate. Then take omega to the left hand side. Sine inverse of 1 means it is nothing but pi by 2. Omega value, it will comes to denominator. It is time. Means this is the time which will take to reach the particle maximum amplitude. Clear enough? And now look at this one. Yes, it is correct. Omega value already calculated now. Put that value here. Pi by 2. Omega means pi by 12. 2 ones are 2 6 are and pi cancel. Hence t is equals to 6 seconds. T is equals to 6 seconds aa gaya. Yes. This is the time the wave or the particle which takes to reach out the maximum amplitude. Maximum amplitude. Then we need to calculate only this portion, right? Yellow color ka portion. We know that up to a by 2 it is taking 2 seconds. Look at here. Up to a by 2 it is taking 2 seconds. Maximum wavelength tak, maximum amplitude tak, it will take 6 seconds. Then what will be this time? They are asking a by 2 to a, right? This is obviously 4 seconds. Right? Then simple, it is 6 minus 2 is equals to 4 seconds. Hence correct option will be here. Option. Yes. Option B. Let me know how many of you are understood this equation or this question. Quickly. Right? Amazing. Cool. Meanwhile, if you are getting any doubt, please reach out to me here. That's right. We'll go through the next question. Note on this one. Or else you will get these notes in a respective link too. Cool. Yes. Okay. Look at this question. Read the question once. Read the question. Question says here, an object, okay, of mass m is placed at a distance or at a height re. At a height re means here radius of the earth. I will explain the question. Okay, from the surface of the earth. Find the increase in potential energy of an object if height of an object is increased to 2 times of re. We need to calculate how much potential energy will be increased. How much potential energy will be increased when the object is moved from at an height. This is surface area. This is actually earth. Okay, already object is present here. Radius ke upar hai. Okay, now I'm going to shifting this one to 2 times the re. To bring this object from re to altitude, from re to altitude at an height to re, how much potential energy you need to potential energy you need to give. That is what we need to calculate. Okay, कैसे calculate करें इसको? How to calculate this one? You need to know the concept first. Okay, this is earth. Okay, on the surface of earth, object is there means its potential energy we will write as an minus gm small m by re. This is small m, the object which is placed on the earth. Capital M represents the mass of earth. Now already they are saying mass is present at an altitude re. Okay, means the radius times it is already in height r. Okay, mass is present over here. Now I'm bringing this object, I'm going to take this object at an height from this position to at an altitude 2 times RE. Now the object is here. To bring the object from point, I will take this point as an E, okay, to representation. For our representation, I will make this one as an, this is a point A, this is point B. From A to B, to take the object from A to B, how much potential energy I need to waste? Or how much potential energy the object will be gained? I need to calculate this. Okay, first we'll calculate at A. What is the potential energy at A? As per the formula, UA is equals to minus GMM divided by RE. Look at you. This is a point, means this RE is an altitude, and this distance will be, we need to calculate from the center of the earth, right? Then it will become 2 times RE, right? This is 2 times RE already. Then at A, its potential will be 2 times RE. Correct now? At A, its potential is already 2 times RE. Next, at point B, the potential can be written as here minus Gm small m divided by, now look at here, this is 2 times RE. Already I pushed this object to 2 times RE above the earth surface, right? Means totally kitna ho gaya? It will be 4 times RE. Right, now I need to calculate the potential energy between these 2 points. Means I need to calculate final potential energy minus initial potential energy. Right, what I'm saying? Now look at this one. UB minus UA, I need to calculate. UB minus GMM divided by 4 times RE. Okay, minus of minus, it will become plus GMM divided by 2 times of RE. Right, what I'm saying? Now next to that, we can take just a minute, everything is fine, right? Okay, everything is fine. Take common here, minus GMM divided by RE as a common. If I will take this much common, means first thing here, it will be remaining 1 by 4 plus 1 by 2, 1 by 4 plus 1 by 2, right? Okay, now it is nothing but 0.25, 0.5. It is nothing but 3 by 4 ho gaya, right? What I'm saying? Then it will be minus Gm small m divided by RE. It will be 3 by 4. Okay, answer is not matching, right? Answer, it is in the form of mg. Dekho. Hence, we can write here, look at here. We know one more equation. What is that equation? Acceleration due to gravity equation. Might be you remember. G is equals to Gm by RE square. Now, if you're going to multiply this RE to G, okay, then it will be RE square into G is equals to Gm. Now replace this one with that equation. Correct what I'm saying? Replace it. Okay, or else if I made any mistake, means we'll get to know very soon itself. Okay, then that equation can be here minus Gm ke in the place of Gm we can write, in the place of Gm we can write GRE square. Okay, GRE square small m divided by RE into 3 by 4. Okay, 3 by 4, 3 by 4, 3 by 4, there is no option. Okay, once we'll check, RE may RE cancel ho gaya, then it will be minus GRM 3 by 4. I will check where I made mistake. Okay, just a minute. Once you cross check, guys, if we did any mistake, means we'll get to know it. Meanwhile, you also go through it once. Exactly, here the mistake done. Yes, actually, object height increase it to 2RE. Okay, from here it is 2RE, means total height will be 3RE hota hai. This is the point where I made mistake. Okay, this is 3RE. Sorry for that one. Okay, it is nothing but 3. Okay, if you will do this one now, you will get here 1 by 6. 1 by 6. Okay, it will be 1 by 6. It will be 1 by 6. You need to take from the surface level, right? Already they told it is at a height of RE. Okay, next we are increasing the height of object from the surface level to RE. Hence it will become 3 RE times. Okay, I made their mistake, a small mistake. Okay, rearrange that one. Hence the correct option will be here, option B. Option B is the correct answer. Clear enough? So clear enough? Let me know in a chat box once. Is it clear? That's great. We'll go further. Yes, it's a time to good to go. Yes, look at here. A moving coil galvanometer, coil 200 tons. The coil has 200 tons. Is connected to torsional spring of constant K. Spring constant they given, the value is 100 SI units. Okay, they given their value of spring constant in terms of, look at here, K is equals to 100 SI units. Okay, and it is placed in a magnetic field. Magnetic field value they given is equals to 0.01 Tesla. If at current I is equals to 4 milliampere is flowing, then that needle will be make deflection. Needle deflection will be here 0.05 radian. Okay, find the area of the coil. Guys, you might be remember. Okay, we need to calculate here area. Okay, this is actually number of tons which is wounded like this. Okay, here this is a number of coil here. Okay, now in between that we'll place one spring. Okay, this is having a spring constant also, means it will be helpful for when current will be moving inside this moving coil galvanometer. Coil ke andar current it will be move, means it will create some magnetic field. At the time this torsional spring will be moved to the means it will shows the reading. Okay, that is basically torque hota hai idhar. Remember always, don't behead this formula always. Okay, मान लो this is the needle. Okay, this needle will be deflect up to this much. Okay, d theta, rs theta, whatever it might be. Okay, here on this needle there is a torque will be act. Torque का value होता है k theta, right? And due to this magnetic field also there is a value of torque. Torque is equals to mb sin theta. Might be you guys know mb sin theta. ये दोनों torque आपस में it will be equal. Hence we can write here k theta is equals to mb sin theta. And you guys know one thing, here the theta value should be 90 degree. When sine will be maximum, that time only the torque value will become maximum. And also if the deflection will become if the deflection will show some 3 milliamp or 4 milliamps like that, it will, when the current will be drawn extracted from the device, it will comes to 0 again when the value will be 90 degree. That's why we need to take here 90. Sin 90 means kya hota hai? It will be 1. Hence k theta is equals to, this is magnetic dipole momentum. The value of magnetic dipole momentum is NAI. Might be you know this one, into B. Now they are asking about area, right? Right, what I'm saying? They're asking area. If I want to calculate area, take everything to left hand side. Then k theta divided by NIB is equals to I. Right, what I'm saying? Then next to that, substitute all the values they given. K value they given, right? Here in the right corner, dekho, the value of k they given 100 SI units. Write down here 100. I will write in the form of 10 to the power of 2. It is very easy to calculate. And theta 0.05. Shall I write this one 5 into 10 to the power of minus 2 radian? It is good, right? Then it will be 5 into 10 to the power of minus 2 divided by n, number of tons they given here 200. Look at the question, right? And then I, the current which is flowing here 4 milliamps. Milli means 10 to the power of minus 3 into B, magnetic field value also they given 0.01 Tesla. I will write this one as 1 into 10 to the power of minus 2 is equals to I. Right. Okay, calculate all these things. Okay, this is equals to not I, this is equals to A. I'm sorry. Here I need to calculate area, right? That's why. Nobody is responding in a chat box. Okay, I made a mistake here. Cool. Okay, area I need to calculate, right? Cancel it all these things. You will get here answer nearly 675 meter square. I already calculated this equation. That's why I'm writing here. Okay, do calculate. You will get 675 meters square. Cool. Is it correct what I'm saying? Wonderful, wonderful. Meanwhile, guys, if you are not getting anything miss, please drop your doubts in a chat box. I will try to resolve your doubts. Clear enough? Yes. That's great. Well, okay. Chalo, we'll go to the next question. Interesting, yeah. Okay. The question: find the magnetic field at point P, which is equidistant from the both the wire. You can see this figure in the bottom. Right now, एक wire है. In this wire, the current is moving upward direction. The magnitude value is around 8 ampere. Right? You can see this one here. This is 8 ampere, which is going upward direction. In another wire, the current is moving downward direction. Its magnitude around 6 ampere. Right? Okay. May I know the direction of magnetic field at the point P? How to find out the direction of magnetic field? Simple. This is the wire. In this wire, current is moving upward direction. Means at this point P, I need to calculate the magnetic field. Means take your right hand, put your thumb in the direction of current which is moving, and curl your finger. When you curl your finger at point P, the magnetic field will be going inside. Right? What I'm saying? The magnetic field will be going inside. Well, and next to that, in this direction, next to that, there is another wire. Here, current is moving downward direction. Same, put your thumb in a current direction, curl your fingers. When you will be curl, at this time also, at point P, the magnetic field will be going here inside. Means simple hai funda. Okay, if I will call this one as a B1, if I will call this one as a B2, both the magnetic field are going in a same direction. Right? If they are going in a same direction, means the net magnetic field can be calculated by using B1 plus B2. Am I correct? Let me know in a chat box once. Am I correct, guys? Okay, great. Right? Well, now to calculate this B, magnetic field intensity, we have a formula for a straight current carrying wire. Right? Can you remember that formula? B is equals to mu naught I divided by 4 pi sine phi 1 plus sine phi 2. Sine phi 1 plus sine phi 2. Let me know. Did you remember this formula? Do you know this formula or not? Okay, well, here you need to imagine one thing here. The wire which I'm giving here, it's an infinite wire. Okay, or else you won't get the answer. Because it's a memory based question, might be the question which is framed here wrong ho sakta hai. Okay, that's fine. If it is infinite wire, we know that phi 1 and phi 2 value will become 90 degrees. Right? If they will become 90 means, then the value will become here mu naught I 90 plus 90 sine 91 sine 91 means it is nothing but 2 divided by 4 pi r. 2 ones are 2, 2 it will be cancelled, then it will become mu naught I divided by 2 pi r. R is the perpendicular distance from the wire which is carrying magnetic field, a wire which is carrying the current. This is the formula to find out the magnetic field intensity. Am I correct? Let me know in a chat box quickly. Meanwhile, if you are getting any doubt, please do ask me in a chat box. Right? Okay, well, we'll calculate the net magnetic field here. Net magnetic field will be here B1. Okay, B1 के लिए mu naught I1 divided by 2 pi R1. Okay, they said like that both the wire from the point P, they kept at a equidistance. Equidistance means it is nothing but total distance is 7 centimeter. From that point, we can take off, right? 3.5 of that. I will write this one first, R1 itself. Next, mu naught second current divided by 2 pi R2. Right now, then next to that, dekho, from this point, you can clearly notify here few things you can take common. Right now, R1 and R2 both are same. Hence, take the thing outside also. You can write simply if R1 is equals to R2, you can write R itself, koi problem nahi. Hence, it will be mu naught by 2 pi R itself, then I1 plus I2. Right? Next to that, mu naught divided by 2 pi into R. R value will be 3.5 into 10 to the power of minus 2. Because it's half of the distance, right? For that reason. I1 plus I2. I1 is the value of I1. What is that? 8 ampere. Look at the figure. Okay. 8 plus I2 value will be 6 ampere. Correct now? And you know one thing. Okay. Mu naught by 4 pi is 10 to the power of minus 7. So what? I will write here multiplied by 2 and divided by 2. Hence it will become 4 pi by using the multiplication of 2. Right? Then the value will be 10 to the power of minus 7 into 8 plus 6. It is 14 into 2 means 28 divided by 3.5 into 10 to the power of minus 2. Okay. Do calculate this one, guys. Almost simplified. You will get nearly 8 into 10 to the power of minus 5 Tesla. Okay. 8 into 10 to the power of minus 5 Tesla. Hope it is understood to everyone. Let me know in a chat box once. Okay, well, cool. That's great. If you have any doubt, please drop your doubt in the chat box, or else we can further move for the next question. Okay, shall we move? Okay, this is the next question. Try to find out this answer actually based on the same type of question we solved. Okay, try to go through here once again. Find the change in potential energy. We need to calculate the change in potential energy of the particle of mass m is taken to a height of 3 times the radius of the earth above the earth's surface. I will give you exactly a minute of time. Okay, take a minute of time and calculate the potential energy. Because already we calculated the potential energy now. That's why potential energy minus G m small m divided by R. Here it is. Check करो. Okay, shall we calculate it? I will give the hint, then you can calculate by yourself. I will give the answer. Okay, this is earth of mass m. First, we are going to keep the object here of mass small m at a distance r. Now I'm going to shift this mass, okay, at a altitude 3 times the RE. Means up to here I will take. Up to this point, I will take this object. Okay. Now they are asking what is the potential energy to take the object up to that point. Right? From this point to here, the value is 3 times the R. Okay. Solve this one. I will give the hint. How 2 to 3 hints I will give. Look at here. Potential energy on the surface. I will call this one as an A point. This is the point B. Is equals to minus Gm small m divided by radius of Earth. Potential energy at B is equals to minus Gm small m divided by. Now it will become 4 times. Right? 4 times the RE. Exactly. Okay. Calculate this change in potential energy UV minus UA. You will get here exactly 3 by 4 times of mgRE. Okay. How to calculate? Already we calculated one question. Okay, it is better to go by yourself. Okay. Conversion you have to remember. Acceleration due to gravity is equals to Gm by R square. We can write Gm is equals to G R square. This is very important. Okay, don't forget this equation. Cool. Yes, we'll go for the next question. Okay, this is another one good question here. You can analyze. Okay, let's go through the question. A charge of 10 microcoulomb is placed at the origin. Okay, 10 microcoulomb I'm going to place at the origin. Where should a charge of 40 microcoulomb be placed so that on the x-axis such that electric field is 0? Electric field is 0 at x is equals to 2. Priorly what they are doing now, one charge is kept at one point, another charge is kept another point. Then between these 2 points, they will give the distance between the 2 particle charges, and they will ask like that, where should be the along the line joining point electric field intensity will be 0. But this time not they given in that common pattern. Okay, they actually twisted. Okay, look at here. Actually they're saying this is at x is equals to 0, right? X is equals to 0. At this point they kept a charge of 10 microcoulomb. Okay, from x is 0 say at this point means 2 comma 0, right? X value they given here, not x value. I can't able to say like that x value is equal to 0. I can say here at 2 comma 0 the potential electric field intensity should be 0. Here electric field intensity should be 0. So for what? We need to keep this 40 microcoulomb charge on this x-axis. I don't know where should I need to keep this 40 microcoulomb charge. Q value will be 40 microcoulomb. So for what? Here it makes combination mein electric field intensity here 0. How? Okay, I don't know this distance. So for what? I will call this distance as an x. It's cool, right? Yes. We know one property. This is positive charge. This is also positive charge, right? If the electric fields are going like this, means this electric field are also coming like this. If they will be repel each other, if they are same charge. At this point, we can clearly say that electric field intensity will be equals to 0. Right now, the same funda is happening here. The same thing happening here, right? But the charge, it is depending on the charge quantity. If they are equal means then electric field intensity will be 0 at equal point, means midpoint. Now the charge, one is at 10 microcoulomb, second one is 40 microcoulomb. So for what? I don't know how to make this equal to 0. We can calculate this one by using this formula, right? E1 is equals to kq by r square, right? If electric field intensity due to this charge, if it will be equal to this charge, then at this point field intensity value will be 0. That's why I'm writing this one. Okay, similarly, E2 value can be written as K Q2 divided by R2 square. We need to equal these two. How? Look at it. K Q1 is 10 microcoulomb divided by R1. Q1 is placed from the field intensity 0. R1 it is at 2 distance, 2 unit distance. So for what I will write 2 square, it is nothing but 4. Okay, well, I will write 2 square itself is equals to next KQ. It is nothing but 40 microcoulomb divided by. Now, what is this distance? From here to here, this distance is x square, right? Okay, well, now from K, this K will be cancelled, microcoulomb se cancel, then 10 ones are 10 fours are, right? Then look at here, x square is equals to 4 into, this is also equals to 4, it will comes to this side. Simply we can say x square is equals to 16. Right now, x is equal to root 16, means x value will becomes here 4 units, right? X value here it will become 4 units, means from this point it will be at a distance of 4 unit. Total distance from the origin will be 6. Okay, they are asking from the origin, hence we have to select x is equal to 6. Clear enough? Right? Is it clear? We'll go for the next question. Yes, that's great. Okay, this is a question which is from AC current. Okay, simple question. If R is equals to 80 ohm, XC is equals to 130 ohm, XL is equals to 70 ohm, find the power factor. Simple. Means here they are giving LCR circuit. Means inductor, capacitor, resistor. Okay, the given inductance value, self effective inductance, it is XL is equal to 70 ohm. Capacitance, effective capacitance, okay, reactance, not capacitance, effective reactance of the capacitor is 70 ohm, and then resistance they given 80 ohm. Power factor they are asking. To calculate the power factor, we need to calculate here power factor. Power factor phi can be written as here, you might be know, it is nothing but R by Z, right? R means resistance, Z means it's a total impedance of the circuit. Total impedance क्या होता है? It will be under root of R square plus XL minus XC whole square, right? Okay, well, R is nothing but 80 ohm divided by under root of R square, it is nothing but 80 square plus XL minus XC. Look at here, XL, XC is 130, right? Okay, shit, 130. Okay, XL minus XC means 70 minus 30. It will give 60, minus 60 whole square. Kuch problem nahi. It will become 60 square only. Correct now? Minus also will become plus when its power will be square. Right? Then next to that, 80 divided by under root of here 80 square. I will write this one as like this. 8 square into 10 here na, 10 square, it is nothing but 100. 8 square into 100 plus 6 square into 100 for my simplification. Then 80 divided by, look at here, 100 we can take common. 100 we can take common. If it is coming out of the square root 100, then it will become 10. Okay, well, remaining thing will be here 8 square plus 6 square, 10 ones are 10 eights are. Then it will be equals to 8 divided by 8 square plus 6 square. It is nothing but 100. If it is coming out of the root means again it will be 10. 2 4s are 2 5s are. Then it will become 4 by 5. Look at here. They given a value of power factor as an 4 by 5. I will tell you one more further calculation process also here. Might be next time they will ask like this. Okay, the power factor value. Okay, what they given here? Look at here, power factor they given 4 by 5. Okay, power factor means we'll say this one as an cos phi. Okay, they will ask the angle, phi angle they will ask. When at the time you need to find out the angle also. That's why I'm writing here cos phi is equals to 4 by 5, or else phi is equals to cos inverse of 4 by 5. Cos inverse of 4 by 5. क्लियर है ना? आर एस cos 4 by 5 का वैल्यू भी पता कर सकते हैं हम कैसे? I will write in this left hand side. Look at the left hand side. Okay, look at this one. In right angle triangle, guys, we know that this is phi. Okay, this height we will write as an for the we can say like the like tan theta को लिख सकते हैं ना हम, right? If it is 37 degree means it is 3, this is 4, this is 5. कुछ अलग बात तो नहीं है. This is for tan के लिए लिख सकते हैं इसको, right? What I'm saying, if in case I will take this one as cos means it is nothing but base by hypotenuse, hence here cos phi will be equals to 4 by 5. It is nothing but phi, it is giving 37 degree. Right now you can write this one as an phi is equals to 37 degree too. Is it clear? Let me know in a chat box once. Is it clear, right? Hope it is clear. Answer is 4 by itself, 4 by 5. In a further, if they will ask means you can calculate it. Okay, cool. We'll go further. Yes. Okay, it's a simple question, guys. I want to know who will give the first answer for this question. It's a curiosity question because it's a very simple question. Okay, basic idea like question. Who will give the answer first? Look at here. They're saying a real object placed in front of the plane mirror. Here, in front of the plane mirror, they place a real image. And real object. The image will be, what kind of image it will be create? You know, this is a plane mirror means if any ray will be incident on it, like this. Okay, from this surface, it will be reflect back like this. Okay, if I'm going to extend the reflected ray backward direction means at this point, image will be created. Right? Image is creating at this point. This image actually it's an virtual image. It's an virtual image. Virtual means we can't able to catch that image on the screen. We can say this virtual image name as erect image. Okay, and might be when you are standing in front of the mirror, your right hand should be looking like a left hand and left hand side is looking like a right hand. Okay, this phenomena we called as an lateral inversion. Right? And then find out the answer. And if you are standing in front of the mirror means exact your size will be appear inside the mirror. Obviously your size will not become bigger than you are, lesser than you. Correct? Now same will be same. Hence we can say here it's a lateral image, erect and same size, but not real. Options but I cut it the options. Simple either it will create inverted image, lateral inversion and same size. Clear? चलो चलते हैं. देखो इधर and length they will ask. Okay, object distance also here it will be equals to image distance. Is it clear? Okay, well. We'll go to the next question. Come on. Find the object distance such that the final image is formed at 5 centimeter. Final image is formed is at 5 centimeter behind the plane mirror. Okay, final image where it is forming behind the plane mirror. Okay, we need to calculate the object distance. Okay, look at this figure once properly. It is better. Look at this figure. Okay, this is a convex convex lens. Okay, from the convex lens to the mirror, the distance is 20 centimeter. Right, this saying the final image is formed behind the 5 centimeter. Okay, मान लो it is the light which is incidenting like this, or from this object it is incident like this, after then it is incidenting like this. Okay, मान लो it is going here, not like that, like this. Okay, it is going behind the screen. At this point it will forms the image. Okay, now, but it is a plane mirror. If it is plane mirror means it will be reflect back like this. Here the final image will be formed. This is actually real image. Okay, this is at 5 centimeter. They are saying means this is also must be 5 centimeter. And don't go with the geometry. Actually, geometry मेरा थोड़ा खराब है. It is actually not good. Okay, just I say मैंने बोल रहा हूँ. If you want means I can redraw it, but it will take too much of time. So for what I'm saying, yes, this is 5 centimeter, right? Okay, now they are asking the object distance कहाँ रखना है. Look at here. This is 5 centimeter में image हो रहा है. Then look at it. This is 20 centimeter from the mirror to here. And they given one more point also. The focal length of the mirror. Find the distance such that the final image formed at 5 centimeter behind the plane mirror. Okay, sorry. One day, here it is. Here. Focal length they given 10 centimeter. It is enough to find out the object distance. How? 1 by v minus 1 by u is equals to 1 by f. This is the lens formula. Take minus 1 by u to right hand side. Then it will become 1 by v minus 1 by f is equals to 1 by u. V ka distance we know that. Look at here. Focal length is 10 centimeter. Image is forming. Just a minute. Just a minute. Is there any mistake I done? No. Yeah, everything is cool. I will simplify this one. Okay. If I'm taking LCM means VF over V minus F is equals to 1 by U. Okay. U value will be comes to be here VF divided by V minus F. Okay. थोड़ा मेरे geometry mistake हो गया ना. For that reason, I am also got confused here. Okay. Apart from that, everything is cool. Everything is cool. Okay. Final image is forming here. Look at this one. This is 20. Here forming. Look at this. This is 20 centimeter. Image is forming at this point. This point means from the mirror it is 5 centimeter and the focal length is 10 centimeter, and then the remaining distance will be here. It will become again 5. Means the from the lens it is forming image at a distance of 15 centimeter. Right, at the 15 centimeter it is forming the image. Look at here. Substitute the values here. The image will be at 15 centimeter. Focal length is 10 divided by 15 minus 10. It will become 150 divided by 5. 5 ones are 5 threes are. Means the object distance should be 30 centimeter. Object distance should be here 30 centimeter. Hence the correct option will be here. Option A. Cool. May I know, is it clear for everyone? I done my geometry is thoda kharab hai. Okay. Try to understand the geometry. Okay. And calculate it once, you will get to know the answer. Okay. Cool. Okay. We have a last question. Okay. This is the last question, guys. After then, we'll wind up this session. Clear? Okay. In this question, I will tell you we need to match the following. Okay, we need to match these two columns. First, they are saying the Planck constant. Planck constant means it is nothing but h. To find out the h, we know one thing. What is that? E is equals to h nu. Right? H we can calculate from here. H is equals to E by mu. E means it is nothing but energy. Guys, E nothing but energy. Energy we will say like that m L2 t to the power of minus 2 divided by frequency means 1 by time, or else we can say time inverse. If it will be comes to numerator, okay, 1 by time inverse, like frequency is nothing but 1 by time. Yes, exactly. Okay, if it is come to numerator, there's a small mistake then. Where? Just a minute. Energy means it's nothing but work done, right? Work done is equals to force into displacement. M L t to the power of minus 2 L2. Okay, correct. Hai? Frequency is nothing but second inverse. Second inverse t to the power of minus 1. Okay, if it is comes from numerator means t to the power of plus 3 hona hai. I will check it once. Just a minute. Is there any wrong information by you here? Not sure. Just a minute, guys. Energy mu means 1 by frequency. E by mu, right? Second inverse. It will become plus. Then okay. Next, it will become numerator means minus 1. Hence, it will be m L2 t to the power of minus 1. Okay. Hence, this is matching here. Look at this one. Planck constant. Here it is matching m L2 t to the power of minus 1. R means A is matching R. Hence, A and B, those options are right. We'll check it, everything. These two options are coming out of the link. Okay. Then next to that, is that work function. आपको पता है work function is nothing but work function h mu, right? Now only we calculate the value of h. Okay, h is nothing but here m L2 t to the power of minus 1. Nu means again it is nothing but second inverse. Okay, t to the power of minus 1. Hence it will be equal to m L2 t to the power of minus 2. Now match this one. Work function is equals to m L2 t to the power of minus 2. It is at P. Means almost all A is matching. Right? And next to that, viscosity. Might be you know that. Viscosity. Coefficient of viscosity pata hai na aapko, guys? Coefficient of viscosity in fluid mechanics, eta is equals to force divided by 6 by RV. Do you know this one? I think here F means force. Force ke liye we can write m L2, sorry, m L t to the power of minus 2 divided by 6 is constant, pi is constant, no need to worry. Then R is a radius, then it will become meter, and then velocity, meter per second. Second we can write here, okay, second time. Meter cancel, it will be m t to the power of minus 2. L will becomes numerator means L to the power of minus 1. T it will comes to numerator means it will be plus only. Denominator of the denominator will becomes numerator. Hence it will become minus 1. Okay, then it will be yes. Almost all it is matching from option A. Hence you can choose option A is a correct answer. Right? Hope you guys understood the topic, how to solve the questions. Okay. Meanwhile, if you had any doubt means please drop your doubt in the chat box. Okay. Thank you for watching the class. Okay. We will meet in a tomorrow class. It will be from 4 to 5, right? I will catch up you now tomorrow class. Until then, take care. Bye-bye.